Hi, my name is Shreyansh Soni, and today I will be demonstrating my project for real-time rendering. In this video, I will be demonstrating my implementation of recursive painting based on the 2023 paper by Akleman et al. The core idea is using a rendered scene's own output as input, recursively displacing pixels using their color values to produce real-time painterly effects. I'm running this in real time using OpenGL. The scene contains a 3D model of a church, and I have MGUI set up to change the models to a city and Suzanne the monkey. Here you can see it is rendered normally before any effects are applied. I have an MGUI panel as discussed before where I can control all parameters live during this demo. Let's first discuss the core paper implementation. The paper's algorithm takes the red and green channels of each pixels and uses them as a 2D displacement direction. This is applied recursively 6 times per frame, each iteration reading the results of the previous one. Watch what happens as I enable it. The flat render immediately starts to look like brushwork. No brush model, no stroke segmentation. It's purely emergent from the feedback loop. I can control lambda, the displacement scale, here. Lower the values give subtle texture, higher values give wild expressive shots. The first extension adds two things that the paper doesn't have. First, edge detection. I sample the 4 neighboring pixels. Here, measure the brightness difference and use that to concentrate strokes along contours. Watch how the strokes now cluster around the silhouette of the model as I start it. Second, brightness bias. The bright areas receive stronger displacement than dark areas, mimicking how a real painter applies more pressure in the lit regions. I can tune both with these sliders. You can see the effect change in real time. My second extension adds spatial awareness using the depth buffer. I sample the depth buffer and use it to scale displacement strength per pixel. Far objects dissolve into loose painterly marks while close objects stay relatively sharp. Toggle here, you can see the background becomes more abstract while the foreground stays defined. This gives the scene a natural depth of field quality without any actual depth of field processing. The second part of this extension uses view space normals from the gbuffer to steer stroke direction. I rotate the color displacement vector by the surface tangent, computed directly from the normal. This means on a curved surface, strokes wrap around the contours rather than pointing in uniform directions. But here's the most interesting emergent property. Watch what happens as I rotate camera away from the model. Notice how the strokes on the side surface becomes longer and more directional as I look away. This is because I'm working in view space. Surfaces facing camera head-on have normal pointing straight at you. Their tangents are small in screen space, giving compact taps. But surface seen at a glancing angle have tangents that lie almost parallel to screen plane. So the displacement travels much further, before folding back. This gives the model a genuine sense of 3D solidity. The strokes themselves communicate the curvature, shorter where the surfaces face you, longer, more sweeping at the edges. This wasn't explicitly designed, it fell out of the view space math naturally. And I think it's one of the most visually compelling properties of the implementation. To summarize, I implemented the core recursive displacement from the paper and extended it with edge away stroke concentration, brightness weighted displacement, depth based spatial smudging, and surface normal strokes orienting with emergent view dependent elongation. All parameters are live controllable. I will now demo for a few more seconds the pre-baked templates that I have so that you can see the different effects it can produce. Thank you.